Hi, everyone. I'm sitting here with Dr. Bill Harris, who is a professor at the Sanford School of Medicine at the University of South Dakota. He is the founder of OmegaQuant, a company we will discuss in detail in a little bit. And he's also recently started the Fatty Acid Research Institute, which aims to understand the health effects of various fatty acids, including the omega-3 fatty acids, which is why I'm pretty excited to be sitting here with Dr. Harris. He has spent the last 40 years researching fatty acids and in particular omega-3. He has over 300 publications on fatty acids, and many of them including the omega-3 fatty acids. Most of them, yes. And so today we're going to talk about a lot about omega-3. And most people that have listened to the podcast or watched the podcast know that I'm a bit of an omega-3 enthusiast. So you can imagine I'm very excited to have this conversation today. We're going to talk about, generalized omega-3s, what they are, the effects on cardiovascular health and all-cause mortality, perhaps on the brain as well. So lots of stuff to look forward to here. So maybe we could take just a step back for a moment, and because omega-3 fatty acids, there's 3 of them, and most of the time I'm focused when I think about my enthusiasm for omega-3, I think about the marine sources.
Yes.
Of EPA and DHA, but there's another source, ALA. Do you mind just spending just a brief moment kind of?
Sure. Yeah, so right, so we generally put them in 2 camps. There's the plant-based omega-3s and then the fish, seafood-based omega-3. And alpha-linolenic acid, ALA, is the 18-carbon omega-3, 18 carbons long, omega-3 compared to the 20 or 22 carbon long marine omega-3s, EPA and DHA. And they are all in the same chemical family, as you say. They're classified as omega-3s because they have a certain chemical structure. But they are not, it's like, third and fourth cousins. They're, in my view, the ALA has not got the cardioprotective benefits of EPA and DHA. I mean, there's some studies that have shown some benefit, and it's good. I'm all for it. But people very often confuse those 2 sources. They think they'll list good sources of omega-3. They'll say salmon and sardines, then they'll say chia seeds and black walnuts, and just throw it all in together, and it's very misleading because the plant-based omega-3s are not nearly as potent as the marine omega-3s.
So the plant omega-3s, ALA gets converted into EPA in the body, correct?
It can be, yes.
It can be, and this is one reason why, when you look at the essential fatty acids, you see ALA on there and not EPA and DHA, yeah. Correct?
Correct.
Which irritates me, but
well, you're not alone.
Yeah. What do you think the best source of the omega-3s would be for someone who is a vegetarian or a vegan?
Vegetarian or vegan would be an algal oil. So the original source of EPA and DHA in a fish is not that they make omega-3. They don't really make omega-3 any better than we do, or make EPA and DHA. They eat preformed EPA and DHA, and it comes from their food sources, which at the bottom of the food chain is these single-celled microalgae. And I'm not talking about seaweed, but these little organisms that convert sunlight into fatty acids, some of which are omega-3. And so different companies have identified which specific strains of algae, microalgae, will make DHA or EPA or both. And they've commercialized or they industrialized it and they harvest the oil. It's an expensive process at this point.
I want to discuss a seminal paper, what I think is a seminal paper of yours that you published back in 2004. Mm-hmm. You co-published with Dr. Von Schacke about the omega-3 index, and the omega-3 index being an important risk factor for cardiovascular disease.
Right.
Can you explain to people what the omega-3 index is, and let's get into why you thought and think it's a risk factor for cardiovascular disease?
Yeah, it's great. Just a little background on how Dr. Von Schacke and I came up with this idea is we were together in 2002 in Chicago at an American Heart Association meeting, and Dr. Christine Albert from Harvard had just presented her study where she looked at blood omega-3 levels in the Physicians' Health Study. And they had stored blood from when they recruited the men into this Physicians' Health Study. It was an observational study. And they had frozen blood samples. And they, after 17 years, they looked back and saw that they had a certain number of sudden cardiac death events in the Physicians' Health Study. And so the theory had already been out there from 10 years earlier that a high omega-3 would protect against sudden cardiac arrests. This from animal studies and some human stuff. So the Physicians' Health Study said, well, let's go look at the blood that's in the freezer of these guys who died of sudden cardiac arrest and compare it to some controls who didn't die, just case control study. And they analyzed the blood and they found that those men who had the highest omega-3 levels at baseline when they started were like 90% less likely to be a case, experience sudden cardiac arrest and sudden cardiac death. So Clemens and I were sitting after this talk, having a beer, talking about it. And we said, look, this is the omega-3 level in the blood means something. I mean, it really does predict. I mean, this is the second study that's shown it. But this is the first one that had been prospective. It really is just like a risk factor, like cholesterol is, except this is one that you can modify easily and without taking drugs, without going on extreme diets, without having to change your lifestyle completely. You can just eat more fish or take supplements, and you can raise your omega-3 levels and reduce risk. So we said doctors ought to be able to know their patient's omega-3 level so they can do something about it. If you don't measure it, you can't control it, right? Manage it. So we kind of said, well, we got to make up a test. We got to, we both had laboratories, so we could say, well, we can do this. So ultimately, we, over the next 2 years, wrote this paper, brought the evidence together, and explained why we think and what we thought a target omega-3 level ought to be. And we called it the omega-3 index. We didn't really know what to call it. Didn't want to call it red blood cell EPA plus DHA. It's too much. And we picked red blood cells because that had been used in past studies, and it makes sense because it's a long-term marker of omega-3 status, because the omega-3s are in the membrane of the red cell and in most other tissues in the body, all other tissues. So it was a good reflection of other tissues. And so we, again, wrote this paper, published it in Preventive Medicine in 2004, and said, here's the omega-3 index. It ought to be, people ought to start looking at this like a risk factor. And that's kind of what's happened. It's slowly, I mean, this is now, 17 years later. It's not certainly recognized by the American Heart Association or the NIH or anybody as an official risk factor, but hopefully someday it will be. In the same sense that CRP took a long time to be kind of considered a risk factor. Omega-3, I think, definitely deserves it for a variety of, not just heart disease, for a variety of reasons. But
what's the biggest difference between measuring EPA and DHA in red blood cells, the omega-3 index, versus, you mentioned they're in the membranes of the cell, which is indicative of many things, and it's also long-term. But most of the time, if people are going to go get omega-3, most people don't ever get their omega-3 measured. Right. It's very rare. But,
very rare.
But if they do, they often get plasma omega-3 or phospholipid omega-3.
Right.
What are your thoughts on the differences there?
There are differences. One problem that I have with the plasma is it's just more noisy. Day to day, it varies. Because, especially if you're in a non-fasting state, if you've just eaten, you've got now triglycerides with fatty acids coming into the blood, changing the denominator, because it's a percent of total fatty acids. And if you're just had a big meal, that's going to change your plasma percent EPA. where it won't affect your red blood cell. So the red blood cell is very much like a hemoglobin A1C relative to a plasma glucose. It's the same concept. It's a more stable long-term marker. It's not affected by daily fluctuations, whereas plasma levels are. So that's one thing I don't like about plasma. Plus, very few studies have really used plasma. It's hard to know what the target omega-3 level would be in plasma.
Do you think the omega-3 index is indicative of EPA and DHA levels in every different organ, including the brain, or is there some?
Well, yeah, you hit it. Almost every organ, probably but the brain. The brain there's this blood-brain barrier, of course, which is very careful to take in what it wants. The brain has got a huge amount of DHA, almost no EPA in brain tissue. I mean, obviously in the blood flowing through the brain, it's there, but yeah, the correlation between the red blood cell and brain tissue is not nearly as good in brain as it is in heart, liver, muscle, every other internal organ, where the red cell does reflect much better. Numerically, maybe a different value for red cell versus liver, but the correlation would be very good. The higher the omega-3 in the red cell, the higher the level in the liver. But it may not be the same number, same percent.
Do you think the red blood cell omega-3, the omega-3 index, is better indicator of brain than plasma? I think I.
Well, probably, yeah, probably better than plasma. And I think you just have to, part of the brain just turns over so slow. You know, red cells turn over in 120 days. Brains, I don't know off the top of my head how fast brain cells turn over and are resynthesized. But I suspect it's quite a bit longer. Turnover time is much longer.
So you've measured omega-3 index in, I mean, just many people through publications and Omega Quant. Do you see, are there like huge variations in people that are given or have the relative like average amount of dietary intake of omega-3 is similar? Do you see that there's still variations in the omega-3 index?
Yeah. Probably an even bigger variability is the variability in response to taking an omega-3. So we look at the delta, the change in omega-3 index at with different dosage groups, and it can be, you know, on average, it's a very nice, the higher the dose, the higher the omega-3 index. But if you look at the individual splay across those increases, some people will, on 1,800 milligrams of EPA, DHA, they might go up from an omega-3 index of 4 to 4.3. Others might go up from 4 to 8. I mean, it's just huge variability, and we don't think it's compliance all the time. I think there's some just a lot of land to cover between your mouth and your blood. So, average American's roughly 5% omega-3 index, which is EPA and DHA in red cells as a percent of the total fatty acids in the red cells. So 5% of the fatty acids in the red cell membrane are EPA and DHA. Japan, it's on average 9%, 8, 9, 10%, because they eat so much more omega-3 than we do. Vegans are down around 3.5%, as are U.S. military personnel, I'm sorry to say. When we've studied the soldiers, that's about the same as a vegan, and you know they're not vegans. So they're not getting enough omega-3. So 4%, we like to say be over 8%. That's the goal. That's been our target. So you can get up to about 15 or 16%. We have seen 2 or 3 people out of hundreds of thousands that are over 20%.
Wow.
Which is weird. But that's, I mean, a dolphin here at SeaWorld, which we studied, and that's all they eat is fish, right? And they weigh about 200 kilograms. I mean, they're big mammals like us, and all they eat is fish. And their omega-3 index is around 18 or 19%. So I think that's about as all that you can get into a cell membrane.
Wow.
There's only so much. The body will only let you put so much, because when red cells are made, they're made to be able to perform a function, and the fluidity of the membrane is very important, and somehow or another, bone marrow knows how much polyunsaturated fat can go into that membrane, and it just is enough.
So you mentioned that target omega-3 index being around 8%.
Yeah.
And let's talk about why that is. You very recently published a study that correlated the omega-3 index to all-cause mortality,
Right.
was able to even predict mortality.
Right.
Very, very interesting study. I shared it on social media, but I would love to talk about it.
Yeah, sure. It's going to be probably one of my capstone studies, I think, in hindsight. It was a collaboration among 17 different cohorts, like the Framingham study is a cohort, Women's Health Initiative is a cohort, MESA, EPIC. These are all, and from all around the world. These are groups that have been recruited at one point in time, blood samples taken, fatty acid levels measured in that blood, and then the investigators just follow this group of people over time to see what happens, what kind of diseases they get, who dies, who doesn't. And so we had 17 of those pooled together and around 45,000 people altogether, where we had omega-3 levels at the beginning, and then roughly the total follow-up time when you're looking at risk for death, all-cause mortality. You obviously look in a given window of time, because if you wait long enough, it's 100%. Everybody dies. So you can't wait forever. You got to wait. So we looked basically between age 65 and 75. Who died in that window of time? And we found that the people that had the highest omega-3 levels compared to the lowest were 15% or so less likely to die over that time. And it was when you look at quintiles of omega-3, it was very dose dependent. The higher the omega-3, the lower the risk. And that was for total mortality. We then looked at cardiovascular mortality, cancer mortality, and then everything else. Kitchen sink. If it's not cancer, not cardiovascular, it's group 3. And we saw the same thing in all groups. It wasn't as strong in cancer. It wasn't as stair-steppy like it was in cardiovascular. But the highest group in omega-3s did have a significantly lower risk of death from cancer. But interesting to me is the non-cardiovascular, non-cancer, all these other causes of death, from electrocution to suicide to car accidents to kidney failure, everything people die of. The higher the omega-3, just like cardiovascular, lower risk. So there's something very systemic, very protective across many many systems in the body. Many diseases, I think, are just held somewhat in check by having a higher omega-3. It's not just heart disease. I think that's the message to get out. It's not just heart disease.
Right. And this 15% decrease in all-cause mortality, was that about a 5-year? Was it translated to about a 5?
We didn't, in that study, we didn't try to get at that, because basically that meant if in that window of time you were 15% less likely to die.
Okay.
How long you actually lived, we didn't follow people till they died all the time. But in another study we published from Framingham, just one cohort, we did see that there's roughly a 5-year difference. If you're at the very lowest omega-3 versus the highest, your odds of dying are about 5 years earlier.
Can you say again, so the omega-3 index for the lowest was?
Was that probably under 4%? And it's for the upper level, roughly 7%. And this is observational in Framingham. Nobody's supplementing. So we haven't got many people over 8%. This is, people living in Boston. And so they don't have high omega-3 levels. But the highest quintile was about over 7%.
You said the average in the United States was about 5.
5-ish.
So 5-ish. And what's the average intake of fish in the United States?
Fish, well, what is it, 13 pounds per person per year, and that's all fish. Right, so that includes, shrimp, which has 0 omega-3, and whitefish, pollock, which is the fried fish that people get at McDonald's, and salmon itself, which is one of the highest omega-3 fish, certainly one of the highest that people actually eat. That provides about 1.5 grams per serving of omega-3. The average intake of EPA and DHA in America is something 100 to 150 milligrams a day. The median intake is 0. Okay. The average, because some people eat a lot and a whole lot of people eat none.
Wow.
So the median is 0, at least to 2 decimal places. But the average intake is 120 milligrams a day. Japan, it's roughly 900 milligrams a day.
900 milligrams. And
for life, for minus 9 months.
wow.
They're on, because moms do it too. Yeah.
And they, if I remember correctly, their average lifespan is about 5 years longer than the United States average.
Right, despite the fact they smoke more, despite the fact they have more hypertension, despite the fact they have a higher stress life, they still live 4 or 5 years longer.
Does omega-3, is it known that if it has any effect on smoking in terms of like negating some of the negative?
Well, that's, in our most recent paper in Framingham, we asked the question, in general, we're trying to understand how much of a risk factor is omega-3 compared to things you already know for death. So we know cholesterol is a risk factor. We know blood pressure is a risk factor. We know diabetes is having diabetes. We know being a smoker is a risk factor for bad outcomes. So how does omega-3 compare to that? And we found that in the study we did in Framingham, looking at all-cause mortality, that if you're a smoker and you have a low omega-3, you're 50, over the 10 years of the study, you're 50-50 chance of living. You're going to die, a 50% chance of dying. If you have a low omega-3 and you're a non-smoker, it's not so bad. Your risk of death maybe is 30% over that. If you're a smoker and you have a high omega-3, that's the other flip side, but you're a smoker, your risk is kind of like having a low omega-3 and being a non-smoker. And then if best case, you don't smoke and you have a high omega-3, your odds of dying are like 10%. So it's, in a way, having a low omega-3 is like being a smoker. But I don't mean to say that taking omega-3 erases your risk of being a smoker. Don't want people to think you can do that. I keep smoking, I just take some fish oil, I'm good. That's not the deal. We do know that smoking actually lowers the omega-3 index. Smokers have lower omega-3 index than non-smokers from other studies. And it could be because of the hyperoxidative state of a smoker's blood that could actually destroy omega-3s potentially. Right. Or they just don't eat fish oil, or they don't eat fish. That's the other explanation. So the general tack of both of our study in Nature Communications on total mortality with our 17 cohorts and this latest one in American Journal of Clinical Nutrition in Framingham point to having a high omega-3 level is protective in the same sense that having a low cholesterol is protective, in the same sense that having low blood pressure is protective. It's about the same predictive value.
And that's about 8% of omega-3 index around.
Again, if it's over 7 in Framingham. But in the pooled analysis of those 17 cohorts, it was roughly about 7.8%. The highest quintile was roughly about the 8% target. So we felt that our original 2004 idea that 8% would be the target, which was based on much less data back then, has been vindicated. It continues to be vindicated. It's been seen that 8%, it's not perfect. I mean, in Japan, you actually get a additional reduction in risk at 10% versus being at 8%.
Have you looked at the correlation of the omega-3 index with inflammatory biomarkers?
Yeah. Mm-hmm. And as you expect, we did this in Framingham. We looked at 10 very different inflammatory biomarkers. that in the plasma in patients in Framingham and correlated it with the omega-3 index, and all 10 of them. The higher the omega-3, the lower the marker. So it's across the board. It isn't just CRP. There's also some phospholipase A2, PLA2, PPLA2, that's the one, which is kind of an inflammatory marker as well, very different. It's a very different chemical than CRP. Some bone-related inflammatory markers were reduced in association with omega-3. So it's there. And giving omega-3 does lower inflammatory levels.
Right. So I was going to say,
That's
like for people, like there's the mechanism by which these inflammatory markers lower, which omega-3s lower the inflammatory markers, and there's a wide variety of them. So you have, I for a long time I always thought of EPA being the anti-inflammatory omega-3, which isn't entirely accurate because all these metabolites of DHA and EPA are
anti-inflammatory.
Well,
not just anti-inflammatory, they are pro-resolving of inflammation.
There we go. Yes.
Which is the flip side of, you can either prevent an inflammation from starting, which may not be good because inflammation at one level is important. But if you don't have the omega-3s on board, the active process of shutting down the inflammation once it starts, that shutdown is inhibited. So the inflammation stays longer. It isn't just that they're anti-inflammatory, they're pro-suppressing of inflammation, which is the important piece.
Right. Because as you mentioned, you're talking about, you want to be able to activate your immune system when there's a pathogen, that's there, but you don't want it to remain active and spiral out of control.
Right. The chronic.
But in the context of just, let's say, not a pathogen, let's talk about this low level of just chronic, immune activation, this chronic, inflammation.
Yeah.
That can be caused from a variety of lifestyle factors.
Sure. Just obesity.
Exactly, obesity. What role do these specialized pro-resolving mediators, the SPMs as they're called, and resolvins and
protectins and moracins and poxytrokins and poxytrins, and there's a bunch of them now. It's actually a bewildering array of molecules that have been discovered, made from EPA and DHA, that operate on different cell types, on different receptors through different mechanisms, but at the end of the day, they suppress an inflammatory response and keep it from getting out of control. So I don't know really the answer how the presence of those resolving mediators plays into the chronic inflammation of someone who's just got a lot of adipose tissue. I assume it will just keep a damper on it, keep it down. Again, what we saw in Framingham was all these mediators are inversely related to the omega-3 level. I don't think that's the mechanism by which omega-3s are cardioprotective.
What do you think the mechanism?
I think it's much more likely to be an anti-inflammatory mechanism and anti-platelet. So thinner blood, less likely to clot. We've been fascinated recently to look at what's called the RDW, the red cell distribution width. And we're just preparing a paper on this now. The red cell distribution width is just a metric that comes out whenever you do a complete blood count, a CBC, on a patient. They get their hemoglobin, the hematocrit, the mean cell volume of the red cells, and they get this thing called RDW, red cell distribution width, which is really just how varied are the red cell sizes in your blood. Ideally, red blood cell sizes should be all the same size. So the coefficient of variation would be very thin, very narrow. So if you divide the standard deviation by the mean, you get a coefficient of variation. That's the red cell distribution width. So it's expressed as a percent. If you have a high percent distribution, you've got, it's a remarkable predictor of all kinds of adverse outcomes independent of everything else. I mean, last 10 years, this has been discovered that for some reason, this how your red blood cells, the variation in size of your red cells is a big predictor of outcomes, bad outcomes. And if you have a lot of little cells and a lot of big cells, and a wide bell curve of red cells, that is bad. you want to have a very steep, sharp distribution of red cells. And the omega-3, so we were interested in, since we measure the omega-3 in red cells, maybe instead of just being a passive vehicle that's carrying omega-3s around the blood, allowing me to measure omega-3 status, maybe they're actually affecting red cell biology. Maybe they're really changing the way red cells carry oxygen, pick up CO2, squeeze through capillaries. Because red cells got to squeeze through half its diameter as it goes through a capillary. So it's got to be very flexible. And omega-3s will help make that membrane more flexible.
Right.
So it could be that we're actually delivering more oxygen to tissues when you have a high omega-3. Haven't tested this. This
fascinating.
Is all. I mean, I'd love to test this. So it is really very cool that, and again, we've seen that we've got a data set of 40-some thousand people. We see a very strong correlation between high omega-3 and lower, healthier RDW. And we're getting ready to submit that now. But the ways that omega-3s may be protective, we may have never thought of yet still, which makes it hard to explain to people how they work.
Absolutely.
It's easy to say they lower triglycerides.
It is.
I get that. But
it is.
So what?
It's probably, exactly, there's so many mechanisms, they're doing so many things. And,
yeah.
That membrane fluidity
yeah.
with the red blood cell membranes itself, that's super interesting. Another thing, I'm sure you're familiar with Dr. Ronald Krauss's work on small, dense LDL particles and how those are more atherogenic. And, the larger buoyant LDL seems to be more cardioprotective because it is transporting, fatty acids and cholesterol and things to cells. And it's the small, dense ones that really kind of get stuck in the arteries and start this inflammatory cascade. Well, he's also shown, him and his collaborators and colleagues, that, inflammation can basically, cause a larger buoyant LDL to form a small dense LDL.
Oh, really?
The inflammation plays a role in that process. And it would be great to have that sort of panel in the physician's, toolbox, right? Where they measure the omega-3 index. They're measuring the small dense LDL. And, it's like, oh, your omega-3 index is 3%. Well, you got to take some fish oil or...
Right, and raising your omega-3 index is going to have implications all over the body that may not be even measurable in a blood test that are good things.
Right.
Like this red cell biology. It just behaves better. It's a more efficient mover of gases or something like that. Anyway.
So you also had a recent study kind of going back to the resolving of the inflammation aspect. What I think is very relevant in, our 2021 world that we live in.
COVID world?
Oh, yes, the COVID world, where we have a pathogen that is, in some people, causing a very bad cascade of inflammation.
Right.
So you published a study looking at the omega-3 index and COVID-19 associated mortality.
Right. Right. We did that with colleagues here in LA. I don't know which way I'm pointing, but
I probably should have said the pilot preprint. It hasn't actually. Has it been peer reviewed? It's not been peer reviewed, or
oh no, it was peer reviewed and published in January. Published in January. And it was a pilot study because we only had access to data from 100 people, which was too bad. But we did have omega-3 index levels in 100 people that had been admitted to Cedars-Sinai in LA with COVID. And so we asked the question, well, is there any relationship between how they did they live or die, and their omega-3 level? And it turned out if we looked, and again, the distribution of omega-3 levels was very narrow. Like I think it probably went from a low of 3 to a high of 5, something like that. But the distribution was narrow. So we weren't able to see, the people that had an 8% didn't really. Nobody there in the study had an 8%. So we looked at the people who had the highest quartile of omega-3 levels, the 25% highest compared to everybody else who was lower. And those people were really half as likely to die. Another paper's come out from Chile, it's just confirming the same thing. They saw the same thing.
Okay. What about Japan? Do you know what because their omega-3 index is higher?
Yeah, I know.
Do you know their mortality?
I know a group has looked at this worldwide, and they looked at WHO data on COVID death, and they looked at reported fish intake on the countries. And they did it by 6 different regions around the world. And what they showed, you know, the higher the average fish intake, the lower the risk of death from COVID. Okay, it's hard to know. So many variables
right,
there.
Of course.
But just it sings the right song. What that specific paper, was most interesting to me about was not this worldwide population thing, which was just their introduction. They were doing in silico experiments, looking at the spike protein on COVID, and they found that there's 2 conformations, an open and a closed conformation. And if it's open, then it can interact with the receptor.
H2 receptor, yeah.
If it's closed, it can't.
Right.
If you got high, they found that DHA, again in silico experiments, if it's present, will hold that thing in a closed position.
You're kidding.
No. So it will not interact with the receptor and not be taken in. I mean, that's the theory. So
that's a huge deal.
Because they also showed that linoleic acid did the same thing.
Oh,
I mean, that's
really?
That's what prompted them to look at DHA. Somebody else had published linoleic acid had the same kind of effect, potentially effect. And so they looked at DHA.
And that's an omega-6 fatty acid for people
Correct.
that are not aware.
It's the classic omega-6, right? So not all omega-6 are bad. Okay.
Well, that is a very...
I'll send you that paper.
Thank you. Yeah, I mean, the fact that both DHA and linoleic acid could keep the spike protein in a closed.
Yeah, so I mean, again, a completely different mechanism than suppressing inflammation. This would actually suppress infection.
Well, it would also suppress, negative outcomes, severe outcomes through the renin-angiotensin system, like that whole thing not happening, like the bad stuff.
Yeah, right.
So very cool.
That's cool stuff.
Since you mentioned linoleic acid, and I kind of know there's so many people out there, that talk about the omega-3 to omega-6 ratio and how the omega-3 to omega-6 ratio is so important. Everyone's so concerned about eating too much omega-6, which, the dietary sources, major dietary sources these days are vegetable oils, refined oils, but, getting them through. And then people have become scared about getting them through whole foods, like eating nuts and flaxseed and healthy food. Yeah. So what do you think? What are your thoughts on this index?
Well, I agree. I mean, the ratio, I mean, the concept, well, we haven't got that much time. It makes some sense. It's very imprecise. Because when you say omega-3, you don't know what you're talking about, ALA, EPA, or DHA. It could be any of them. And when you say omega-6, you don't really know. There's 7 omega-6 fatty acids in the blood. Which ones are you talking about? And so you don't know what this ratio, you can't act upon it because you don't know what you're acting upon. The other problem is you can have a high omega-3 intake and a high omega-6 intake, or low omega-6 and a low omega-3 and have the same ratio. So that doesn't help because the problem is that you can fix a bad ratio by taking more omega-3, and that's the right way to do it. But you cannot fix it and improve your health by leaving your omega-3 intake alone and just lowering your omega-6, which that ratio people tend to do that. They think, well, I got to fix it. Well, the way to fix it, there's only one way to fix it. It's a good way to fix it. It's to eat more EPA, DHA. That's fine. If you want to play that ratio game and fix it that way, okay. But don't take it any further than that.
100% agree with you. That's my thoughts. Is that really it's the low omega-3 intake that's the problem, and that you need to increase that omega-3 intake. So, what does your personal omega-3 intake look like?
2 to 3 grams a day from supplements. I don't really have a favorite supplement. I kind of, maybe like your friend in Norway, if people send me supplements, try this. And then salmon, probably once a week for sure. Try to do more, but at least once a week. So my index is around 10.
Are there any other areas of omega-3 research, like maybe sports medicine, joint health, the brain?
Yes,
I mean,
yes.
we still have a little bit of time.
We do?
We do.
Well, brain, we're working on a paper right now, again, from one of our cohorts, looking at the omega-3 index predicting risk for Alzheimer's and dementia. And it does, which is nice. But that's kind of what you'd expect. We're looking for an interaction with ApoE4 genotype, and not quite there. I think probably sample size is not, but it generally, I mean, if we control for ApoE levels, we still have a significant benefit of high omega-3 if we control for it. But if we stratify by ApoE4, non-ApoE4, it looks like the benefit is a little better. The curve is steeper, the relationship is stronger in those that are at the higher risk, i.e. have E4, than in those that have low risk. But I think because our sample size is too small at this point, we can't get an official interaction p-value.
So that it's actually the preventative power is better in
people who are sicker, who are at higher risk.
Right, higher risk.
Which is kind of what you'd guess.
And this is a great work because, a lot of the omega-3 brain or dementia or Alzheimer's disease research has always been fixing someone who already has it, trying to
and
improve memory, and I mean,
very hard to do.
Very hard to do. Yeah,
I mean, horses out of the barn.
It is. So if there are people that do have a genetic risk for Alzheimer's disease, if they know that they can increase their omega-3 index by supplementing with omega-3 and or increasing their fatty fish like salmon or sardines that have high omega-3 in it to prevent and stave off dementia, I mean, it's very important, and it's like low-hanging fruit. It's low-hanging fruit.
It's a very safe way to help reduce risk. Put it off for X years. We don't know how many years maybe you're putting off dementia. We'd like to try and figure that out.
Well, since we're talking about the brain, I mean, another area that I am very interested in, much like your daughter, who is also a PhD,
yes.
and she's also a registered dietitian as well.
Right. Christina Jackson.
Dr. Christina Jackson, is the role of omega-3 in development. And, you guys at OmegaQuant are doing some really interesting, gathering some interesting data because you are looking at, and maybe you can talk about this, how you're looking at the omega-3 index in pregnant women and in lactating women.
Yeah, right. I think one of the high points in omega-3 research has been a Cochrane report from a couple years ago, reporting that looking at 70 trials in pregnant women given omega-3, that the giving omega-3 reduces risk for premature birth, especially early premature birth, before 34 weeks. Premature birth, garden variety, is before 37. But the effect on reducing risk for early premature, which is the most challenging one for the baby and the mother and the NICU and the entire financial system. Reducing risk for that. In fact, in this meta-analysis, Middleton was the first author on this meta-analysis. They said, at this point, no more research should be done on this. The question is settled. And we think being over 5% is where you want to be. I mean, there's no guarantees you're going to prevent preterm birth. There's so many factors that go into why a woman delivers early. But from the risk factors we can control, if you're down at 3%, that's the high risk group for preterm birth. Over 5% is not a problem. So it's something a obstetrician could easily measure. Dried blood spot test could measure that and counsel a pregnant woman, you're too low, take more, you're already supposed to take DHA. People know it, but if you have a blood test that says you're low, you might actually do it.
Right.
It's the compliance issue, I think. So that's an important area of research now to try to figure out how to operationalize that, get that in the clinic, get the use of an omega-3 test in pregnancy in the clinic.
It had this 5% omega-3 index. You're talking about it in the context of potentially helping prevent premature birth. What about
development.
Brain development.
Brain development, yeah. I mean, that's the other side of it. We're looking at mom and the delivery issue with premature birth. But yeah, there's plenty of evidence that having a higher omega-3 level in mom, I mean, it's mixed evidence, as is everything. If you look several years down the road, kids are doing better in some studies.
Yeah.
They're not doing worse. They're never doing worse. They're either doing no different or better.
Right.
Yeah. And so there's a long-term benefit probably to the kid for having higher omega-3 in utero.
Mm-hmm. I think there was a recent study that was published where it was a randomized trial when women were given like 200 milligrams of DHA or 1,000.
Right. It's Kudos. It's a study from, Adore was the name of it, from Kansas University, Susan Carlson. They published it, and they found a benefit in preterm birth. But they also found benefits in other adverse outcomes, reduced risk for adverse outcomes in the delivery. They aren't, at this point, they haven't looked at mental outcomes in the baby. This is all about birth.
Okay. All right. So I'm thinking of other studies. But yes, so a very important, I think.
Yeah, I mean, omega-3s are just important across the entire lifespan.
Lifespan, exactly. You're talking about development to the way you age. And in a way, I mean, we're talking about sustainability. That is an issue, but it is a low-hanging fruit to some degree for people that are willing to make that lifestyle
You can't solve
change.
all these problems at once.
Right. And so, like, I know from my mother, who is, she's mostly sedentary, and she kind of tries to eat. She mostly eats what she wants. She tries to follow my advice to some degree. But the one thing that is like consistent about her is she gets her supplements I give her every day, and that includes 2 grams of EPA. And vitamin D, but that's
good.
The low-hanging fruit because it's easier to take those pills than to change your diet. And
as much as we in nutrition would love to say, get it from food, we're real. You got to be realistic. Some people are not going to do it, and so you don't withhold Plan B, which is take it from supplements.
Do you think there is? So you mentioned just this one thing about the doses that I've been wanting to ask you about, the Lavazza and the
Vascepa.
Vascepa. They're sort of like capped at a 4-gram.
Right. That's what originally when the folks at GlaxoSmithKline took Lovasa, it used to be called Omicor. Took Lovasa to the FDA to get it approved. Their studies, they did dose response studies, and they got on triglyceride reduction. And they got good enough at 4 capsules a day of triglyceride reduction, so they said, let's use that. But they got better at 8 grams, better triglyceride reduction. But who's going to take 8 grams a day? Who can afford it? Who's going to act? There's a practical wall you kind of run into. So 4 grams was nothing magic. It's just what the data that was brought to the FDA to get approval for Lovasa. So now everybody's kind of capped at 4 grams. Not because higher wouldn't work better, but
that's what I wanted to ask you. I mean, would you like to see that? I mean, if higher would work better, shouldn't we know that? I mean,
it would be nice to know that. And then you do have the obstacle of, well, how are you going to do it?
Well, I wish we could keep talking more because there's so many more things that I would love to talk to you about. But I just want to thank you so much
You did a great job.
Your contributions to the field and for
it's been fun.
coming out and having this conversation with me. And